Topic 11 review. My smartboard's not working, so here we are. Number 1. If a is greater than 0 but less than 1, okay, so we have a positive a value, so something like y equals 1/2 the square root of x. If you don't know what that does off the top of your head, which is to compress the graph, just put it in your calculator. You look at the square root of x, you look at 1/2 the square root of x. Okay, the first line that pops up is going to be the square root of x, and the next line you see is beneath it. It goes up half as fast. So what we're looking at is a vertical compression that has occurred to the graph of the square root of x. In order to shift the graph to the left 5 units, you must have what? Okay, so you know probably after all this time that if you see something like that, y equals the square root of x plus 5, that you're going to have a shift to the left. But what's really going on there, because the actual format is x minus h, that's the standard vertex form. So this is an x minus a negative 5. Because minus a negative gets you that positive there. Okay? Because the original formula starts with a minus sign in there, then if we want to get this plus 5, which is what we know to be a shift to the left, then h, the actual value of h, has to be negative 5. So that's what a is. Now describe what transfer occurs on a square root function with a k value of negative 4.2. Okay, what does k do in our formula? A times the square root of x minus h plus k. What moves things up and down? Okay, so if it has a minus sign or a negative sign, it's going to be moving down 4.2 units. Describe what transformation occurs on a square root function with an h value of 3. Alright, again, let's look at our square root function. X minus h. What is h? H is 3. So what kind of a shift is that? It shifts the parent function, y equals square root of x, to the right 5 units. Not 5 units, 3 units. And again, graph the function in your calculator. If you don't know what's going to happen to it, just graph it in your calculator. So you know the format, or the general form for the vertex form for a square root function? Square root of x minus h. Minus what? Well, h is 3. So x minus 3, and then look at what happens to that function. You can see it used to be at the start, the square root of x starts at the origin. We started 3 units to the right of that. Alright, number 5, describe in words the transformations that are being applied to the following function. Okay, well let's just go left to right, starting outside the square root. So if we have something that's a negative sign outside the square root, that's a reflection across which axis? It's across the x-axis. So there's a reflection across the x-axis, a vertical compression, by a factor of 1/2. Okay, then what's going on inside the square root of x plus 7, that's a shift to the left, 7, and then the minus 1 outside is a down 1. Now what's the function's domain and what's the function's range? Okay, domain, x values, range, y values. That's y. So for the x values, we were reflected across the x-axis, so even though it's upside down, that doesn't really do anything to our x values. What does do something to our x values is the horizontal shift. So we were shifted to the left 7 units, which means instead of starting at 0, our range is going to start at -7. So this is the domain. We're going to start at -7, and then it will proceed on in the x direction until infinity. And the range, now this is affected by that reflection across the x-axis. So instead of our range starting at wherever the vertex is and going up until infinity, now it's starting at the vertex and it has this shape where it goes down like this. Okay? So the lowest value we're going to have is -infinity, and the highest value that we'll have is this -1. Now, I'm going to always recommend graphing these in your calculator to make sure that you have answered it correctly. No reason not to. Your calculator is a powerful tool and you have access to it. So I have that -1/2, the square root of x plus 7. Okay, so when you get to the end of that, square root of x plus 7, you have to hit the over arrow to get your square root function to stop. Otherwise, the -1 that you put in will not be a k value. It will be still under the square root, and so it will be applied like it's an h value. So just make sure that you end your square root. You see how mine goes all the way to the 7 and then stops. Then we graph it. You can see now it's upside down because we had that reflection. It's a little flatter because of the compression. It was moved to the left by a factor by 7, and then it was moved down 1. Okay, so our domain, -7 all the way to positive infinity, and then our range from -infinity all the way up to -1. So always graph that and just confirm that what you think is happening is what's happening. Write the equation of the square root function that has been reflected over the y-axis, shifted horizontally 2 units to the right, and vertically 5 units up. Okay. So one of the first things that I would notice is there's no stretch or compression. So we're only dealing, and there's no reflection about the x-axis. So A is just going to be 1, which means we're really only dealing with what's underneath the radical, and we're dealing with k. Let's do k first. Up 5 units. K follows all the rules. Plus 5, as you see it, is a shift up 5. Okay. The reflection over the y-axis, that's going to be that minus sign inside the square root. Okay. And then, if you remember, when we do our horizontal shifts, or reflections over the y-axis and our shift horizontally, we're going to put it in parentheses just so that it stays the same as the x minus h that we're used to. So if we're going 2 units to the right, that's an h of 2. And so if we are dealing with x minus h and h is 2, then it will look like that. Y is equal to the square root of negative x minus 2 plus 5. And now there's an equivalent way to write that. You could just write negative x plus 2. So I'm distributing that negative sign with the plus 5 at the end. And I'm going to demonstrate that by graphing both of those functions in my calculator. Square root of negative x minus 2 plus 5, and then the square root of negative x plus 2 plus 5. I hit graph, and hopefully I'll only see one line. I do. Let's go to the table, and you see that if I keep going up, my y1 and y2, all the values are the same because it's the same line, just one has a negative sign that's distributed and one doesn't. So here's number 6. Let's finish this page on this video. Number 7, the following function is transformed by shifting it horizontally 3 left, vertically 2 units down, and the resulting is g of x. Make a table of values and graph the function. So g of x. Let's look at, we've got the negative sign here for f of x reflects it about the x-axis. Then it shifted down 1, and it was shifted to the left 3. Okay, so where do we go from this vertex? All we do is we go 3 more units to the left, 1, 2, 3, and then we go down 2. And there's our new vertex. Okay, and so nothing changes from our values beyond that point. So we're going to go down 1 over 1, down 1 over 1, and then so there's an a here is negative 1, so there's no stretch or compression. So it follows this pattern: down 1 over 1. Down 1 over 1, 2, 3. See, that's the next point. Down 1 over 1, 2, 3. Down 1 over 1, 2, 3, 4, 5. Down 1 over 1, 2, 3, 4, 5. And if I connect those dots, it should look just like that line above it. It's just been shifted. Okay. So we can write the function directly from this line. We could write it from this one. I'm going to write it from f of x to show you what that looks like. Okay. So the square root of x plus 3, or yeah, negative the square root of x plus 3, is being shifted to the left 3. So that's going to be plus 3 in here, another plus 3, and then shifted down 2. It used to be minus 1, we're shifting it down 2 more. And so g of x is going to be negative the square root of x plus 6 minus 3. And you could do that just from this vertex. So once you have moved the graph over here and drawn the line, you know that it's still negative because it's still upside down. A hasn't changed. And then it's a shift to the right, 1, 2, 3, 4, 5, 6. So that's x plus 6. And then minus 3, it's a down 1, 2, 3. So let's put some of those points in there. We've got when x is negative 6, y is negative 3. When x is negative 5, y is negative 4. When y is negative 5, x is negative 2. When x is 3, y is negative 6. And I'm going to go ahead and write this one, even though it's not on our graph. So when x is negative, or when x is 10, y would be negative 7. Okay, so watch this. We've got a gap of 1 here. We're subtracting 1 every time because that's what our a value is, minus 1. Then over here, we have a difference of 1, a difference of 3, a difference of 5, and a difference of 7. So our square root functions will always follow that pattern for every vertical shift of 1. As long as our a value is 1, for every vertical shift of 1, our horizontal shift is going to be 1, 3, 5, 7, 9, 11, so on and so forth. The only reason that this part would change is if there's a vertical stretch, and the only reason this part would change is if there's a horizontal stretch, which happens underneath the square root. So if we had an a value of 2, or of negative 2, then this would just be negative 1 times 2 times 2 times 2 times 2 for the same horizontal stretch, or horizontal values. All right, so here's your table of values, and there's your function, and there's the graph. All right, that took longer than I thought it would. Let's do this one really quick. All right, the equation given the parent function is the square root of x. Okay, so let's look at, because we were just talking about that pattern, let's look at our pattern here. So it is up, so we know our a value is positive. But is it positive 1 or is it positive something else? Well, let's look for the pattern. Up 1 over 1. Okay, that's good. Up 1 over 1, 2, 3. So already I can tell that it's following the pattern that it does when a equals 1. Up 1 over 1, up 1 over 3. If we went up one more, we'd probably go over 5. So a is positive, and it's also 1. So when we write our function, y is equal to the square root of x. What's our horizontal shift? We go to the right 1. So the way we write that underneath the radical is x minus 1. And then we shifted down 4, so we've got minus 4. Alright, so that's the first 8. One more video or two, and we'll get all the way to number 20.